Hi, so let us try to solve this question from one of the textbooks. Determine the force in each member of the truss. Indicate whether the members are in tension or compression. So we have A, B, B, C, C, D, B, D, and AD. There are two external forces, the 400 newtons and 600 newtons, and we have two support reactions. Let's go on revise what we have done in our previous classes. So first one is the hinge support and the other one is the roller support. When we convert them, we need to remember from your notes. So if you have a roller support like this or something like that, it's always replaced by one perpendicular force, can only offer a reaction perpendicular to the surface under the roller. The hinge supports two possible reactions components because a hinge connection can offer support in any direction. So one is the X and Y. So solutions, step one, to solve this equation, we need to draw the free body diagram. Means we replace the support reactions to forces in X and Y direction, or in this case. So this will be in that way. So this is the free body diagram, step one. AY, CY, CX. Now we have three unknown forces and two external forces given. We need to use the equilibrium of concurrent forces, but in this case will be non-concurrent forces because we need to take the moment. So summation of forces in the X direction, summation of forces in the C direction, or summation force or moment, or summation forces in the Y direction. This will help us to determine the values for AY, CX, and CY. Always we need to assume the direction of my positive and negative x's. So when I put this for you guys here, it's represent for me that the positive direction for x is going in that way, and the positive direction for forces in that way for the y direction, the vertical and horizontal. After writing the equation, so summation of forces in the x direction, this is showing you where is the positive. You will end up having only Cx, and opposite to that Cx is the 600 newtons. If you look carefully, there's no other forces in the x direction. Now, if we take the moment about point C here, we'll find C1 and Cx will go from the equation. So we have minus, because I'm taking this direction as the positive, so that will rotate opposite to that, so it will be minus AY times 6, the distance, plus 400 times 3 plus 600 times 4. Rearranging this equation, you will end up finding the value for AY, the support reaction at Y is equal to 600 newtons. The last thing we do to find the support reactions at like point CY, we'll apply summation of forces in Y direction is equal to 0. So you technically, if you look carefully here, you have AY 600 we just found, and 400 external force, and CY which we need to find. So AY minus 400 is going downwards, minus CY going downwards. Rearranging the equation, CY will be 200 newtons. Now, we have assumed the direction of forces and the values came positive. It means our assumptions were correct. Now, after we finish step 2 is to determine the support reactions values. Now we need to find the force in each member, and we need to state if it's compression or tension. So step 3, draw the free body diagram for joint A. So this is joint A. I will take this joint here. I will put, there is a force, external force 600 newtons from the support reaction, and there is a force from the member AD, and there is a force from the member FAB in that direction. I'm assuming it. Again, I'm assuming if I get negative answers, then I need to state it with the correct direction. Summation of forces in the Y direction, upwards going positive. So what you have, if you look carefully to this, so I'm not looking to that one, I'm looking to that joint. So what do you have? You have the 600 newtons going upwards. Against that will be the analysis of the components of AB sine 53.1, and rearranging this, a force of AB, the member is 750. Since it came positive and I'm putting it as a compression, so I put is a compression force. I'll apply the same thing, algebraic summation of forces in the x direction. So what do I have? I have the FAD going in the positive direction. Against is the force FAB going opposite direction. FAB cosine 53.1 degrees. Rearranging the equation, FAD will be 450 newtons. And if you see, I assume it's correct because it's giving me a positive answer and it's tension. Now, if you ask how did we determine the angle 53.1, so you have this distance from that point B to here, it's 4 meters, and from A to that point is giving to us 3 meters, and that's how it's showing you in the diagram in the original question. So tan inverse 4 divided by 3 will give you 53.1 degrees. Now we need to go to step 4, draw the free body diagram for the joint D. If I go to joint D here, what do I have? I have support reaction, was an external force 600 newtons, and member force FDC going downwards, and there is a force FDB is going in that direction inclined, and there is another force in that way, which is the which is known, the FAD. Now you say, where do we get the 450 newtons? We got it from here, FAD in the previous solution for step 3. So that's where it's coming, the 450. I will apply again so algebraic summation of forces in the x direction. So what do I have in the x direction? I have the 600 newtons positive. I have the FDB going in that direction as well, will be positive, cosine 53.1, the same principle of the angle. And in the negative, I have this one, the 450 is going in that way. The answer will be minus 250 newtons. Negative sign means the FDB, we assumed it wrong. It acts in the opposite direction. So instead of being compression, it should be tension. So I write tension and I correct the answer to make you guys understand it or see it. Algebraic summation of forces in the y direction. So what do we have? We have the component analysis for these forces. So minus FDC, or the analysis of this one, minus 250, because we got the answer minus 250, sine 53.1 degrees, and then you substitute that, and then you get FDC is equal to 200 newtons. Now I kept the minus here because still my arrow is saying it's going downwards. If you correct the arrow upwards, then will be positive, and that's what's showing you mathematically. Minus will be converted to positive, and then you get an answer FDC as a compression force with 200s, agreeing with my assumption. Step 5, draw the free body diagram for joint C. This is joint C. You have support reactions 200 newtons, 600 newtons, and then the member CD with 200 newtons. We want to find this member FCB. So algebraic summation of forces in the x direction, 600, it should be equilibrium with that force, so it will be FCB 600 newtons. The arrow is in that direction, is compression, that's why we put C. Need to check 200s minus 200s, that's to check, should give me 0. It's mean I have equilibrium at point C. So let us sum up what we have done in this question. I want you to go through it step by step and try to apply this equation, and you see it. Let's see how it looks like. This is the question we go first. We transfer in it. So what do I have at this member AB? At AB, I have a compression because the direction of force of 750 and 750 newtons. And if I go to the member AD, I have a tension because the direction is going away from the member, so it will be 450 newtons, 250 newtons, 250 newtons. So I think there is an error here. That's not error, that's 400s here, and this is 200 newtons for that force above. So it's just to show you. So that's one for the member AD. Now for the member DB, you have a tension of 250 newtons. So you see the arrow is leaving the member, that's why it's tension. For the member CD, you have a compression. The Oros is going towards the member with 200 newtons, 200 newtons. And for the member BC, you have the forces in compression going towards the member with 600 newtons. So this figure shows the state of each member if it's under tension or compression, and that's why how you show the answer for your questions. I hope you enjoyed this video, and hopefully to see you again with another video or in class. See ya.